Welcome, everybody, to episode one of The Blueprint. We've all had this really satisfying experience of typing a query into a search engine and seeing exactly what we hoped come up. So, what's really the essence of that interaction? Where does search start? Where does it end? What counts as a really good answer? This episode will dive into some of those questions along with Sohaib Katariwala, who is an OpenSearch Specialist Solutions Architect. Hope you enjoy.
My name is Sohaib Katariwala. I'm a senior OpenSearch Specialist SA, and this is John. John, please introduce yourself.
Hi, everybody. My name's Jon Handler. I'm a senior principal solutions architect at AWS and been here for a long time. And hopefully we'll get into that a little bit today.
Yeah, awesome. So let's start there. You say you've been here for a long time. Tell me a little bit about how you got to be in the role you're in and a little bit about that journey.
Search for me has always been a really fascinating topic. The search engine really mediates between something that I want and large pile of information that has the answer to the thing that I want. And how you get from point A to point B, always been super fascinating. I worked on a large scale comparison shopping site building a search engine and then moved to AWS 15 years ago when we were first building Amazon Cloud Search, which was, based on technology that was already at Amazon, that we were creating a public interface and an AWS service around it, and been with essentially the same team through the whole evolution of the product line that started with Cloud Search and that has moved through Elasticsearch Service, Open Distro for Elasticsearch, OpenSearch itself, the open source project, as well as the rename of the service to Amazon OpenSearch Service. So I've really been here through all of the changes and been doing search for a long time.
Were you always interested in search, or at some point in your career you became sort of interested in this?
A little bit of both. Honestly, I did a PhD thesis a gajillion years ago in 19 that was it was really it was a robotic system that built walls out of Duplos. The theoretical part of it though was that it tracked what was going on in the environment, and at each step it would go and try and retrieve the next thing that it needed to do. Right. So the robotic system was somewhat of an implementation detail for the retrieval system that was going and looking at that stuff. And so right after that, I went to again I took a detour through the robotics world, but eventually ended up at websites post, the internet web bubble, late 90s, all of that. Ended up at a website that was like focused on search, and it all lined up the whole way through. Right.
Awesome. Okay, cool. So, this is our first episode, and we learned a little bit about your background. And so, what do you think is like the best thing to start off this podcast with and launch it? What's a great topic that we should discuss today?
Well, how can we not address the large pink elephant in the room? So, in the last 5 years, and especially in the last 3 years, the how we think about search and fundamentally coming back to that, how the relationship between a goal or a desire or a need and information that satisfies that need, that process is going through a disruption right now. And I think it's really important to both focus on what the traditional search methodology provides, what it's good at, what we've done over the last 30 years in just search technology itself, and then put the current emphasis on large language models and chat interfaces and embeddings for semantic search and hybrid search to put all of that into context of the greater kind of search problem. That was a sort of high level, what should we focus on? But I do think that that's going to be part of what we should focus on as we go forward with this podcast. And if
Yeah.
you're watching, please leave a comment and let us know what you'd like to hear us talk about because we're open. I didn't say the L word, which is log analytics, but log analytics, is another potential area where OpenSearch has a lot to offer in terms of analyzing large amounts of my favorite term, digital exhaust, as our
Okay.
as our services produce more and more log data. OpenSearch plays in that world as well, of course. So many different directions we can go in, and we will probably go in all of them. But let us know, please, in comments what you're most interested in.
Absolutely. Awesome. So then should we start with the history of OpenSearch and go from there? Or what do you think is the best place to start discussing with today?
Well, today let's talk a little bit about not so much the history of open. We can talk about the history of OpenSearch. I think, also more productively, maybe just talk about the core elements of what search is and what it tries to provide. Um,
Sure. So what is
yeah,
search?
yeah. What is search? Excellent question. So at the high level, we already said it's kind of mapping some goal onto some set of information. And there's really a long, long history that relates to search technology itself, right? You can go back thousands of years to ancient Sumer, where they used to create tablets when they invented writing, right? Then they invented tablets where they had indexes of data about crops and things like that, right? So even way back in the day, we were trying to create access to specific pieces of information based on indexing or creating a higher level, more abstract view of that information. That path goes all the way through history, really through in the modern world, library science, and then even into database technology, right? So with databases, we in information technology, we have databases. Databases provide us the means of first storing data in a reliable way, but then secondarily being able to write queries that access that data based on the structure and shape of that data, right? So a search engine is in the databases world and provides that same kind of access to the information. Now, there's a distinction between a relational database, which is transactional and really designed for reliable storage, and a search engine, which is designed for fast, low latency queries and designed for high throughput. Because, when folks were writing their relational databases and we had LAMP stack and all of these things where the entire data set was in the database. Turns out those databases, because they're transactional and because they have, sort of ACID limitations, they can't handle the throughput and the latency. They weren't designed for that. So search engines really were a natural extension for a more relational store, a more ACID or transactional store for the data, but still providing that core capability that enabled query to data access. So let me say a little bit more about also indexing. And, we talked about the clay tablets, but honestly, of course, there's no little dude in the machine who's like stamping out the clay tablets for the UI. It
Oh,
doesn't work like
really?
that.
Oh
No, it
man.
doesn't work like that anymore. So the core idea about indexing was to invert the relationship between the piece of data itself and the access to that data. So the core data structure for search engines is called an inverted index. And what does inverted index do? It just takes the values that appear in the various fields in the data, and it maps the value onto the place that value occurs. So, for example, if I have some set of categories that, if I have an e-commerce site and I have a set of categories that each of my products falls into that category, well, there'll be a category index which contains all of the possible categories, and then that points at the list of the documents that contain that category. That makes lookup very quick, right? Because if you have 100 categories, even, you do a quick binary search on the index and you get all of the documents that fall into that category.
Is
Um,
that like similar to, I have a cookbook that has a list of ingredients at the end where I can just say if I want to make something with chocolate, it tells me all the pages where there's recipes of chocolate. So that's the same idea?
it's exactly that idea.
Okay.
Now, it gets a little bit more complicated. So by the way, I'm saying the word document. Let me just quick define that. So when you use OpenSearch, you send an item to OpenSearch for indexing. That item is called a search document. It contains its JSON because OpenSearch has a JSON API, REST API, and it contains the set of JSON fields and values that represent the entity that the item that you're going to retrieve. Again, e-commerce is a very convenient example. So each product likely has a document that contains things like the product name, the product description, maybe a price, the categories that it goes into, maybe some other attribute type information like sizes or colors or other things like that. And so that is the search document. And when you design for search, I like to say this a lot. When you want to design a search solution, start with the document. The document is what you're going to retrieve, and it's what you're going to put in, right? So if you start with a focus on, I want to retrieve products, your document should be a product document. So that's search document. And
Great. Well,
this,
this is it's a good overview of OpenSearch, how do you interact with OpenSearch, how it works. What do you think is the next most important thing for our viewers to know about?
yeah, let me expand a little bit into search document because one of the core capabilities that search is provides, and this is where we start to get into the more Gen AI or large language model things. For their history, search engines have provided native capabilities to take large blocks of text and decompose them into individual matchable terms is the word of art, but you could think of it as like words, right? And I gave the example of brand. Brand is something that is a kind of non-decomposable. It's a single textual unit. You want to match that exactly. But search engines have been designed and built to take something like a description, which you're not going to match exactly, and parse it up and apply language rules that enable queries that are also expressed in language, right, through a text box,
Mhm.
can enable the breakdown of those queries into matchable terms and retrieve documents based on matching larger blocks of text. We call those free text, and more broadly, matching words we call lexical search. And so if you look at the process of the decomposition of large blocks of text into matchable pieces and how we think about the value of any particular document's piece of text, then we get into relevance, which leads us again into how text and meaning and matching happens with all of the AI technologies that are new. And I think we'll get into that a lot in the coming episodes.
Awesome. Yeah, I'm looking forward to it. If you have any ideas and any questions on what John talked about today and you want to learn more about specific topic for our next episodes, please let us know in the comments and we will talk to you next time. Thank you,
Thanks
John.
very much, everybody. Thanks,
All right.
Sohaib.